Okay, this is concept 42, solving exponential equations. Step 1 is to use the properties of exponents to simplify each side of the equation. Then we rewrite the equation so both sides have the same base. And then finally we drop the bases and set the exponents equal to each other. Now, for this first one, here's our first type of problem. Equations with a common base. These are the easier ones. I have 2 to the x plus 1 is equal to 2 to the 9th. And just think logically what this statement is saying. Okay, I have an equation. These two sides are equal to each other. So, if the base is 2 here and the base is 2 here, therefore the exponents have to be equal to each other. And then, just like we bypass step 1 and 2. We don't need to do those. We go straight to step 3. We drop the bases, and therefore the exponents have to be equal to each other just to make this equation true. So what is x equal to? It just becomes a simple equation to solve. X in this case is equal to 8. Right here I have the same base, 5 and 5. My exponent is 4n plus 5 and n minus 7. These have to be equal. These are two values set equal to each other, so they're the same. The base is the same. Therefore, the exponents have to be equal to each other. Solve for n. Okay, I get 3n plus 5 is equal to negative 7. And subtract 5. I get 3n is equal to negative 12. Then I get that n is equal to negative 4. Next one, I have two terms here on the left side being multiplied, and I have one on the right side. Okay, 3 to the k times 3 to the k plus 2. Properties of exponents, same base, so I can add my exponents. I get k plus k plus 2, so I get 2k plus 2. Okay, I added my exponents there. And then that's equal to the right side's exponents, 5k minus 1, because all of these are the same base. I solve for k, get my k's on one side here. I get 2 is equal to 3k minus 1. I'm going to add 1 to both sides. Oops, plus 1. And I get that 3k is equal to 3. Divide both sides by 3. And I get k is equal to 1. For the next one, I have the same base everywhere, 10, 10, 10, 10. So left and right side, I can combine my exponents. And again, properties of exponents, I can add them. So negative 4 plus 9, I'll show all my work here. Negative 4 plus 9 is equal to v plus 4 plus 2v minus 11. I get 5 on the left side, and that's equal to 3v minus 7. Solve for v, add 7 to both sides. Okay, I get 3v is equal to 12. Divide by 3 and I'll get that v is equal to 4. And that's all there is to these type of problems where the base is already the same. For the next set of examples, the base is not the same, but I can rewrite the expressions either on the left or right side so that I do have the same base. So here I have 6 to the 2x minus 10 is equal to 36. I can rewrite 36 so that it's an exponential expression that has the same base. I can rewrite that as 6 squared, because 6 squared is equal to 36. Now I have a common base, so the exponents have to be the same, because again it's an equation. 2x minus 10 is equal to 2. 2x is equal to 12, and then x would be equal to 6. Next one, similarly, I can rewrite 8 so that I have 2 to the p minus 7 is equal to 2 to the third. 2 to the third is equal to 8. So drop my bases, p minus 7 is equal to 3, and I get that p will be equal to 10. Next one, 7 to the 4x plus 11 is equal to 1 over 7. Okay, we just got through this unit. We can rewrite this, the right side, as 7 to the negative 1. Remember our negative exponent rules. Okay, now I have the common base, and I can set these equal to each other and then solve. So I get 4x is equal to negative 12, and then x is equal to negative 3. Number 8, I can rewrite the left side now as 2 to the 5th is equal to 2 to 2m minus 9. So I get 5 is equal to 2m minus 9, and I get 14 is equal to 2m, so m is equal to 7. Number 9, so we start, the level of complexity is increasing now. I have a base 3 here, 27 here. I can rewrite 27 as 3 to the 3rd. Now I have 2x plus 6 already in the exponent there, so I can say it's still there, it's still part of the exponent. I just rewrote 27 as 3 to the 3rd. That's equal to 3 to the 2x. I can merge these here, combine these, okay, using distributive properties. So I have 3 to the 6x plus 18 is equal to 3 to the 2x. And then now I have a common base, and I have 6x plus 18 is equal to 2x. I get 4. Okay, let's see, let's send 6x over to the right side. So I get 18 is equal to negative 4x. And then divide by 4, I'm going to get a fraction in this one, and that's okay. So I get x is equal to, divide by negative 4. And if you simplify this, I'm getting negative 9 over 2. And that's my answer for number 9. Number 10, similarly, I can rewrite the right side as 4 squared, but y minus 3 is still there, still part of the exponent. Now I have the common base, so y plus 2 is equal to 2y minus 6. I distributed the 2. Solve for y. I'm going to send 6 over to the left side, so those cancel there, and I'll send y over to the right side. So I get 8 is equal to y, and that's it. I'm done. Next part, we'll do a couple of these. Number 11, I have 125 to the y is equal to 25. So in this particular one, I'm gonna have to rewrite both the left and right side. So 125 to the y, I can rewrite this as 5 to the 3rd, because 5 to the 3rd is 125. And then I still have the y there. Then I can rewrite 25 as 5 squared. Now I have the common base, so I have that 3y is equal to 2. So then y is equal to 2/3. Whoops, I went through the value there. Y is equal to 2/3. For number 12, it looks like I might be stuck, but again, it's left and right. You have to rewrite both sides so you can get the common base. 16, I can rewrite this as a base 2 to the 4th. And then I can, so 3x is still here, so parentheses 3x is equal to, and I can rewrite 8 as 2 to the 3rd times x plus 2. Now I have the same base, so I have 12x, okay, that's when I multiply the 4 and the 3x. That's equal to 3x plus 6 Then I get 9x is equal to 6. X is equal to 6 over 9, and that's equal to 2/3. Number 13, rewrite 4 as 2 squared times 3x is equal to a to the x minus 1, that's 2 to the third x minus 1. So I get 6x is equal to 3x minus 3. 3x is equal to minus 3, and then x is equal to negative 1. Number 14, I have a fractional base here, okay, but again, you can rewrite this. Whenever you see something like this, you're going to be dealing with a negative exponent, so I can rewrite the right side here as 3 to the negative 1 times 2x, okay, because it's still there. Then I can rewrite 81 as 3 to the 4th times 2x plus 5. Now I have the same base, so I have 8x plus 20 distributed to 4 is equal to negative 2x. If I solve for x, I get, let's see, 20 is equal to negative 10x, so I get x is equal to negative 2. Number 15, I can rewrite 8 as 2 to the third times 2a minus 1. I can rewrite 32 as 2 to the 5th times 2a plus 1. I have the same base, so let's just skip that step. I get 6a minus 3 is equal to 10a plus 5. I'm going to send my a's over to the right side and then the constants to the left side, so I get negative 8 is equal to 4a. So again, I subtracted negative 5 from both sides, then I send the 6a to this, and I subtracted, so I got 4a. So then I get a is equal to negative 2. Number 16, looks like it's a big number. 243 though is, you can rewrite this as a base 3. So this is 3 to the 5th times x minus 2. That's equal to 27 is, of course, 3 to the third times 2x. So I get 6x is equal to 5x minus 10. I get x is equal to negative 10 here. Number 17, I have two terms on the right side, okay, and I can actually rewrite that as just one term. 4 to the 1, right? 4, you can say that's just 4 to the 1 times 4 to the 4x plus 1. You can rewrite the right side as 4 to the its properties of exponents, so you add your exponents. So 4 to the 4x plus 1. 64, you can rewrite this one as 4 to the third. Now I have the same base, so then my exponents are the same. 3 is equal to 4x plus 1. Solve for x, I'm getting 2 is equal to 4x, so x is equal to 2 over 4, or 1/2. Next one, number 18. 9 to the 2x plus 4 times 9 to the 2x is equal to 1 over 81. Again, whenever you see a fraction here, you're dealing with a negative exponent. These are the same base, properties of exponents, so I can add them. So I have 2x plus 4 plus 2x, that's 9 to all of that, is equal to 81 to the negative 1. this base is 9, I can rewrite this one as 9 squared. So I get 9 to the 2x plus 4 plus 2x is equal to 9 squared. That's 81 times negative 1. So now I have the same base. I have 2. I'm just going to let's skip this step. So I have 2x and 2x. I have 4x plus 4 is equal to negative 2. So 4x is equal to negative 6. And then x is equal to negative 6 over 4. And then this is going to be equal to negative 3 over 2. Last two. 1 over 7 is going to be 7 to the negative 1. 49 here I can rewrite as 7 squared, and I have a base here of 7, so that's exactly what I want. So 7 to the 2 to the second times x minus 5 times 7 to the x minus 9. Now I have the same base, properties of exponents. I can combine these now. So I have 7 to the negative 1 is equal to, I'll show this step, 2x minus 10. I distributed the 2 there, times 7 to the x minus 9. Now I can combine them. So I get 7 to the negative 1 is equal to 7 to the 3x. I add my exponents, negative 19. Negative 1 is equal to 3x minus 19, because I have the same base now. Add 19 to both sides. I get 3x is equal to positive 18. I divide by 3 and I get that x is equal to 6. Number 20, I have 4 to the 2x times 1 over 16 is equal to 4 to the 6x plus 18. So I'm going to want a base of 4. So rewriting the left side here, I have 4 to the 2x times 16 to the negative 1 is equal to 4 to 6x plus 18. Now I'm going to rewrite 16 as a base 4. So 4 to the second times negative 1 is equal to 4 to the 6x plus 18. This becomes negative 2. I have the same base. I can add them. So this becomes 4 to the 2x minus 2. That's what the left side becomes. And then now I have an equation of the same base. So I have 2x minus 2 is equal to 6x plus 18. I'm going to get my x's on the right side and my constants on the left side, so I get negative 20. That's when I subtract 18 from both sides, is equal to 4x. I divide both sides by 4 and I get that x is equal to negative 5. And that concludes concept 42.